All right, and we are back. And today, once again, we're back with something a little bit different. I was actually feeling in a really educational mood today, so I figured we'd check out a video more educational. This one is brought to us by our great friends at Kurgesagt. I believe I'm saying that right, so if I'm not, I do apologize. I believe it's a German company, and I'm not great at saying German names. So, with that being said, guys, if you'd like to support me and help me get as big as Cosmonaut, then please like, comment, and subscribe. It's all the fun stuff that YouTube forces me to ask you to do. Because if you don't, they will break in here, and they will. Without further ado, let's go ahead, check out this video. This one's called The Black Hole That Kills Galaxies. So that actually looks pretty interesting. I'm a pretty big fan of like space and astronomy type stuff. Just it's very interesting, space and the sea, two biggest mysteries of our universe. So let's go ahead and figure out space right now with the black holes. So let's get it.
The universe looks like a vast empty ocean sprinkled with rare islands of galaxies. But this is an illusion. Just a small fraction of all atoms are found in galaxies, while the rest is thought to be drifting in between, in the intergalactic medium. Like the roots of some massive tree, gas spreads out from each galaxy, gravity funneling fresh mass into this dense cosmic forest. Here in the intergalactic medium are the raw materials of creation: hydrogen and helium, woven into sheets and filaments that flow into galaxies where they eventually create stars. But if we look closely, we see who's actually in charge: quasars, the single most powerful objects in existence. As small as a grain of sand compared to the Amazon River, they reside in the centers of some galaxies, shining with the power of 1 trillion stars, blasting out huge jets of matter, completely reshaping the cosmos around them. They're so powerful that they can kill a galaxy. What are they, and how do they mold the structure of the universe at their whim?
Okay, so let's see what I know. Quasars. If I'm familiar, they are like stars that are pretty much dying. They're like massive stars that are in the center of like most galaxies, and they're like actively dying. They're like dispersing their energy, and like quasar blast are. I mean, he already said it. It's like the most powerful thing in the universe. The only thing when I was young, I was told that if a quasar hit the Earth, it would destroy everything so quickly that we would only like see that it was coming and then be done for. So yeah, that's pretty much the extent of my knowledge. I believe they're dying stars, but let's find out.
Everywhere you look, weird things in the sky. In the 1950s, astronomers noticed mysterious loud radio waves coming from spots all over the sky. They were named quasi-stellar radio sources, or quasars, because they were dots like stars but were seen in radio waves rather than visible light. Everything about them was strange. Some flickered, others emitted high-energy X-rays in addition to radio waves, but all seemed to be tiny. They all moved extremely fast, as much as over 30% the speed of light. The only explanation was that they must have been so distant that their apparent speed was actually the expansion of the universe moving them away from us. But these enormous distances meant that quasars couldn't just be stars, but the active cores of galaxies billions of light years away. And it gets crazier. To appear so bright and loud, given these vast distances, they are thousands of times brighter than the entire Milky Way. Monsters exploding and screaming into the void with a violence not thought possible before. As we mapped the sky, we discovered over 1 million quasars, and they all seem to be very far away. Looking into space far away means very long ago, because light takes so long to reach us. Quasars were common in the early universe, having peaked in number 10 billion years ago when galaxies and the universe itself were still very young. Let's go back in time just 3 billion years after the Big Bang and see what was going on back then. The incredible power of quasars.
Okay.
How could an early baby galaxy be so incredibly bright and violent? All that light and radiation couldn't be stars, as there weren't nearly enough of them. And since galaxies tend to grow with time by merging, the starlight from small galaxies shouldn't be far brighter than any galaxy today. There's only one way to generate the vast amounts of energy a quasar shines with: feeding supermassive black holes. We still don't know how exactly they formed, but it seems that every galaxy has one in their center. But how can the brightest things in the universe be black holes which trap anything and everything that crosses their event horizon? Well, the light of a quasar is not coming from inside these black holes. Rather, it comes from the space around them, a massive orbiting disk of gas called an accretion disk. Quasars use the same fuel as stars to shine: matter. It's just that...
Okay. So quasars are just like black holes. They're just like really massive black holes in the center of the universes, and they are... what we're seeing is just like all the massive amounts of like material that they're just like absorbing and also spewing out at like super high rates. Because I know like sometimes with like black holes, like even though they do just absorb, they do send, sometimes they can like send a little bit of like that massive amounts of energy back outwards. I may just be talking out of my ass here, I don't know, but if that feels right. That feels right. And you know, most of science is actually based off of feelings, you know? They have this really old adage in science, feelings over facts, you know? That's something every scientist used to say back in the day. I think Einstein invented that.
Black holes are the most efficient engines for converting matter into energy in the universe. The energy released by matter falling into a black hole can be 60 times greater than that released by nuclear fusion in the core of a star, because the energy released by a black hole comes from gravity, not from nuclear reactions. Matter falling into a black hole speeds up to almost the speed of light before it crosses the event horizon, buzzing with an incredible amount of kinetic energy. Of course, once inside the black hole, it takes that energy with it. You only get to witness this energy if you drop your matter in the right way. Fall straight down and the outside universe gets nothing. But when you have a lot of matter, it spirals in incredibly fast towards the event horizon, forming a disk. Collisions between particles and friction heat it up to hundreds of thousands of degrees. In a space not much bigger than our solar system, the core of a galaxy can release many times more energy than all its stars combined. This is what a quasar is. A supermassive black hole having a feast. And these black holes eat a lot. Typical quasars consume 1 to 100 Earth masses of gas per minute. 10 billion years ago, the universe was about a third of its current size, so the intergalactic medium was much less spread out, meaning the filaments of gas around quasars could feed them a banquet, making them vomit insane amounts of light and radiation. The brightest quasars power jets, tangling the magnetic field of the matter around them into a narrow cone. Like a particle accelerator, they launch enormous beams of matter out, plowing through the circumgalactic medium, forming plumes of matter that grow to hundreds of thousands of light years in size. It's almost unfathomable in scale. A tiny spot.
That actually makes sense. So guys, I was right. Anybody who questioned whether I was gonna be right or wasn't gonna be right, I got something to say to you. But I'm not gonna say it on YouTube. So you know what it is. You know who I'm talking to. You over there, you thought I was wrong. You were wrong. So, yeah, looks like I'm a genius.
Spot in a galaxy.
Guys, I'm not actually Kurgesagt. I know you guys are probably like, wait, is he actually Kurgesagt? No, I'm not. Turns out I'm not. I don't even think I'm German.
Carving out patches of the universe, hundreds of thousands of light years long. But quasars can't eat for long, maybe a few million years, because their feast ultimately kills their galaxy. How quasars kill galaxies. Okay, maybe killing is a bit of an exaggeration.
I'm gonna say they probably like just absorb all the material within the galaxy, and I mean technically the black hole becomes the galaxy if you wanna think about it like that. Like where the galaxy was, there's now just a supermassive black hole, and yeah, it's just taking its spot, and it's gonna grow and it's gonna move on to another galaxy and eventually absorb that, maybe get into another black hole and two black holes absorb each other. That happens over time.
A galaxy is still there after its quasar turns off, but it will never be the same again. Quasars, being among the hottest and brightest things in the universe, break their galaxies by heating them up too much and stopping star formation. Stars are gas that collapsed in on itself and then got really hot. But in a cloud of gas that's already hot, atoms are moving quickly. When they collide, they hit hard, exerting pressure that resists gravity's squeeze. So hot gas cannot form stars. Instead, the best gas for forming stars is already cold and won't put up a fight when it's time to collapse into a star. On top of that, quasars push gas out of their galaxies. Not only does this starve the quasar, but its galaxy loses the raw materials for new stars. As sad as this sounds, it might be a good thing for life. The alternative can be far more dangerous: too many stars. New stars forming is usually followed by massive stars exploding in supernovae, so planets would be burned sterile. But of course, it's more complicated. Like the intricacies of our own planet's biosphere, every piece of the galaxy is dependent on and influencing every other part of the galactic environment. While hot things like quasars and supernovae tend to push gas out of the galaxy, shockwaves and quasar jets can also compress gas, making new stars at least for a short time. But in general, we can say that without things becoming a bit more chill, we would not exist today. Which brings us to our final question. Did the Milky Way have a quasar in the past? It's unclear if every galaxy went through a quasar phase, but understanding distant quasars may provide clues to the history of the Milky Way. Galaxies don't do a good job of preserving their history. Like sand on a beach, the endless churning mixes away the clues to their past. It's possible the Milky Way was once a quasar, which may have allowed our supermassive black hole Sagittarius A star to have grown to 4 million times the mass of the Sun. And as dormant as it is now, Sagittarius A star could turn into a quasar in the future. In a few billion years, the Milky Way will merge with Andromeda. We've seen over 100 double quasars in galaxies smashing together, where fresh gas is provided for the central black holes. But it won't last for long. When galaxies merge, so do their supermassive black holes, sinking into the center of their new galaxy, kicking up dust and stars in every direction. We don't know whether this will happen, but it would truly be an incredible sight. Maybe some beings in the far future are going to witness it.
Now, as far as I'm aware, when that does happen, like two black holes actually like merging together, like they spin around and they kind of like synchronize with each other, and then one of them takes over or they become one, there's supposed to be like a really big shockwave from that. So I don't know about like any of these people just seeing it peacefully and happily. It's probably going to be like a super violent affair where like the massive shockwaves are probably like it's two black holes. They're probably going to be shockwaves like that are strong enough to destroy actual planets, if not, whole solar systems at a time. At least shifting them. Like that type of like explosion or that type of like shockwave at that massive scale will probably at least throw quite a few planets out of their, orbit, rearrange whole solar systems. So yeah, it may not be like a super fun thing to watch even if you could see it.
And be in awe of what they see. But you don't have to wait that long. There are already plenty of fascinating things to explore right here on this planet, right now, if you have the knowledge to understand them. To help you with that, we've created...
Guys, that's brilliant. Is there anything that's not an advertisement? Just because, guys, Brilliant doesn't pay me, but you could help if you like comment, and subscribe on this video. Yeah, that's right. With your support, one day I will be cosmonaut. Wait, is that? Yeah. I may have forgot how to fully pronounce his name, so when my editor looks at this video, they'll be able to correct me.
Course, how technology works, hacker, ride share, more. Start your
Advertisement.
Been waiting for a sphere.
That was
Jim
an
with 2 hours, so
advertisement.
soon.
Guys, Kurgesagt, great video. I feel like we actually learned a lot today. Like, it was a very, I like this whole like educational space sometimes. You know, you ever just be in a mood to like want to learn and like talk about things that involve learning? It's fun. So guys, if you had fun today, please again, like, comment, subscribe. But also, don't be surprised if I do a few more of these type of educational videos over the next couple of days. Especially as right now was gonna do a full Rocky reaction, but YouTube blocked it. So guys, if you want to help support, you already know what to do. Go ahead and hit that subscribe button, hit that like, and actually go ahead and leave a comment as well. But guys, I will catch you on the next one. Bye.